Okay. Good afternoon, everyone. How are you guys? Show me a thumbs up if you can hear me, so we can continue with the session. You guys can hear me?
Yes.
Thank you, though. Okay. So let me share my screen. And okay. Okay. For like today's session, we're going to see about model serving and deployment. Yeah, with Docker. We're going to see some of the definitions, what they are, like what fast API is, what Docker is, what model serving is, and we're going to jump into the demo and see it in action. So let's start with the basic one, like what is model serving? What do we mean when we say model serving? So model serving simply means like taking a machine learning model that you trained in your notebook or in your files, like making it available for other application to use. Just instead of just running the model manually, like inside your file, we expose it so that other systems like mobile apps, website, internal tools, or business workflows can send data to the model and get prediction back in real time. So without model serving, your model stays locked inside your file, and it may be accurate and well trained, but cannot help users or customers or the business. So serving is like what turns a trained model into something that has a real world impact. So just serving the chat is not going to be good, right? So if you don't give it to people to use, or if you don't give it to an application or a website to use your model, it's just it doesn't help anyone, so it's not really helpful, right? So we need to serve the model. So how do we do that? There are two main ways to serve the model, and the right choice depends on your use case usually. So the first way is batch prediction. This means we run the model on on a schedule, maybe every hour or every day or once a week. It's useful for like things like risk scoring or forecasting or generating reports where prediction don't need to happen instantly. So for example, like if we have forecasting company in Orangeal or weather, we don't need like every single time a prediction, right? Like we can predict in the morning for tomorrow. That's it. Like we can run that model on a schedule, not like every single time, or doesn't have to run all the time. So this is what it means. Like on the schedule means once, for example, if we want አንድ ፋይል ባች ፋይል like ሙሉ ሰጠነው አንዴ ፕሮሰስ አድርጎ እንዲሰጠነው ማድረግ እንችላለን። that's like one time, right? We don't need it online all of the time. So that's batch prediction. The second way is real-time API prediction. So in this approach, like the model responds immediately, like whenever the new data is sent to it. So it's essentially for use case like fraud detection, like chatbots or recommendation systems, where the systems must act like instantly based on the user's action. So yeah, the difference is simple, right? So batch is scheduled and might be slow. Like real time is instant and interactive. So if you want a customer like walks in to the bank or to our establishment, and we want to assess that customer is like whether he's a high risk or is he going to default. Like we need to put that information down and get the prediction from our model back instantly. So that's what a real-time API prediction is. So we've talked about an API in the 2 slides, but what is actually an API? So, an API stands for like application programming interface, and the easiest way to understand, like the easiest way to understand it is like think of it as like a door that allows like 2 systems to communicate with each other. So for example, a mobile app can like send the user's data through its door, and the API passes that information to your machine learning model, and the model makes a prediction. And then the API sends the results back to the app. So there's usually a basic explanation for API everyone uses. Think of like the API as a servant in a restaurant, and your model or your application is the kitchen, and the users as like a customer. So when a user or a customer order a food, it tells for the servant, right? It doesn't go to directly to the kitchen and order. So the API means here the servant will take the order and tell it to the model or to your endpoint or to your backend. So when the backend or the kitchen, as in this example, sends back the food, still the servant gets the food and delivered to the user. So that's just an API, just a middleman. So when we come to the, for this example, a mobile app can send user data through its store. Yeah, as we said, so API use like standard communication methods like HTTP, GET, and POST request, and they usually send and receive data in JSON format. So this makes it easy for any app, web, mobile, or internal tools to talk to your model in consistent and reliable way. So this is the definition of an API, like simplifying. So why do we use like API for machine learning? So we need API because like they allow us to separate the machine learning model from application that use it. So instead of like putting the model inside the mobile app or website, we need the model on the server and let the app communicate with it through an API. So APIs also gives us a standard way to communicate, like using HTTP and JSON, as we have seen in the previous slide. So any type of application can interact with the model without like worrying about how it was built. So they provide also secure and controlled access, meaning we can decide who is allowed to use the model and track how it's being used. So, API like make it easy to scale as well. So whether it's 10 user or 10,000 users, they can send requests at the same time. So another important benefit is monitoring and logging, which helps us track performance and detect issues. And finally, like APIs make versioning simple. So we can have version 1, version 2, and so on without breaking the existing application. So when we come to our challenge document and what you're going to use in this week challenge. So we use a fast API. So let's see what fast API is. So fast API is a modern Python framework designed specifically for building API quickly and efficiently. So it's currently like one of the fastest API frameworks available in Python, which makes it like great for high performance applications. So it's widely used. And one of the things people love about like fast API is that it automatically generates documentation for your API, which we will see in the demo. So you get a clear interactive docs without writing anything extra. So the syntax is also very simple and elegant, making it easy to learn and it's enjoyable to use. So it's easy. So fast API is like especially like popular in ML projects. You will see them like most often in ML projects. So because it makes serving models like straightforward and efficient. Like many companies use it, like Netflix, Microsoft, Uber, all of them use like fast API in production. So this is what fast API is. Like why do we use fast API? There are several reasons why we use fast API. For example, its performance is simpler. Like when we compare it to Node.js and Go, like it's performed better, and which are like known for high-speed web services, both of them. But fast API is more good and has more performance than them. Fast API includes built-in validation through Pydantic, which means your API automatically check that incoming data is in the correct format for passing it to the model. So it will check. So we will see it in the next slide as well. So this will help us like reducing errors and making your application more reliable. So another great feature, as we have said, it have documentation it's automatically generated documents, and it can handle like many requests at the same time, and easily to integrate with ML models. So this is why we use fast API. So you guys are with me, right, Babu? Maybe you can hear me. Okay. Okay. So we have said like Pydantic. So what is that? Like Pydantic is like data validation library that fast API relies on, like to ensure that all incoming requests are clean, correct, and well structured before they reach your model. So it protects your API from crashes caused by like bad or missing input. So for example, let's just say if your model expects a number, but someone sends a string, so Pydantic will catch that problem immediately and return a helpful error instead of just breaking your application. So it's just a like safety net checker. So yeah, so for example, as you can see here, I just put like a snippet of some code. So age and income, like age has to be like integer and income has to be float. So we defined it here. So Layla value is certain, it will reject it, or it will return you're not using the right value. So this is just Pydantic. It's simple and easy to understand. So when you run the API, this is what you're going to use. We'll see it in the demo, no worries here. But just to give you a clarification here, like we use a tool called like UV-Core, which is a fast and lightweight server. The command like unicorn, like UV-Core, like main reload starts the server and enable the reload feature. So anytime you change your code, the application restarts automatically. So once the server is running, you can visit the API root in your browser to see the root of your API. But if you want like a Swagger documentation, /docs, and if you want the redoc documentation, also the redoc, which we will see in the demo. So yeah, like you can say that like why APIs are like mandatory for ML apps. Why don't we just use our models? So that is like one of the questions that might pop on your head, right? So without an API, like an application has no way to communicate with ML model. So the model will just sit inside your like notebook or on your computer. So completely like inaccessible to any user. So API solves this problem by creating a communication bridge between the application and the model itself. So through this bridge, like apps can send data and receive prediction in real time. They also provide secure and controlled access. So like only like authorized systems can use the model. API ensures that incoming data is valid, like preventing errors and crashes, and because they are built on standard protocol like HTTP and JSON, any type of application, it might be web, mobile, or internal tools can interact with them easily. So uh, they also like are scalable, so that's also one advantage here, allowing many users to make prediction. And the standard protocol, as we have said that. So this is why like every real email project or systems rely on APIs. So without one, your model stays locked inside your machine and cannot provide value to an actual user. So قدم بالنا example, like for the restaurant, the kitchen will just create foods, like maybe the food will be like very good, but if there isn't someone that's will going to deliver to the users, like it's a waste, right? So we need that way. So APIs helps us like deliver to the users. So yeah, that's it for like API. You guys are like asked to do ML flow as well. So let's just see it briefly as well. So what's an ML flow? ML flow is an open source platform that helps manage the entire ML lifecycle from start to finish. So instead of having your experiments, models, and metrics scattered across notebooks and files, like ML flow gives you a structured system to track everything in one place. So it works with any machine learning library, whether you're using skitlearn or PyTorch or TensorFlow or XGBoost and so on. So it fits like naturally into any workflow. So yeah, ML flow like acts as like a central hub, like where you can organize experiment, compare models, and keep your progress clean and consistent. So why do we need it? Why do we need ML flow? As you see here, like ML flow helps you solve unorganized experiments, hard to reproduce results. Losing it will solve hard to reproduce the results, losing model version, difficulty comparing metrics, manual tracking, or parameters. So just down ለምሳሌ you let's say like some value ቀየራችሁ like on the modeling ምን ያህል ጊዜ iterate ያርግ or you might say one time 100 time iterate አርግልኝ ብለን እንለው እንችላለን። oh እስኪ let me see like next time 200 አርጌ ልሞክረው ኢትሬሽኑን እና how the model will perform የሚለውን figure out ላርግ ብትሉ like you'll like log that manually, right? You have to see like 100 ሲሆን እንደዚህ አይነት value ሰጠኝ እንደዚህ አይነት accuracy ሰጠኝ, or like you need to do that manually. So ML flow will automatically like log that for you. You just, if you change something in your like training code, a value, when you run it, ML flow will like track that with this input. You get this output of like model accuracy and so on. We will see that also in the demo. So generally, this is what it does, ML flow. Like it has four main components: ML flow tracking, ML flow project, ML flow model, and registry. So ML flow tracking logs metrics, parameters, artifacts, like we talked now, like ML flow project, packaging ML code for reuse, ML flow model, standard format for saving model, and registry version control for model. So in the future wise, just not for now, but አንድ ቨርዥን ብቻ አይሆንም አይደል ዲፕሎይ የምታደርጉት you will change, you will retrain the models, like new data ሊመጣ ይችላል, better like ideas, you will change in time. So nothing is permanent. So you can version your models as well. So version 1 model, version 2 model, it will help you achieve that ML flow. So the next thing, our final point is Docker. So Docker is a containerized tool, like which means it allows us to package everything our application needs into like one portable unit. So this includes our code, the library we use, all dependencies, even the operating system environment, like all of it. So by putting everything into a container, we ensure that our application runs the same way, like everywhere, on our laptop or on a server or in a cloud. Like there are no more issues, like it works on my machine but not on yours. So like Docker remove all of those environment problems and giving us like consistent isolated space for our application to run. So if you containerized your project, you can send it to anybody, that Mac OS or like Linux or Windows. It will perform like the same in all environments. So the dependencies, like the libraries, won't affect it. So while we use Docker for ML, it solves work on my machine problem, same environment everywhere, easy deployment to cloud, reproducible builds, scales easily, and perfect for APIs and ML models. So the key Docker concepts are image, like, I'm sorry guys, one moment. Sorry guys. Okay. Where were we? Yeah, the Docker concept. So the first is image. An image is like a snapshot of your template of your application, and it includes your code, library, dependencies, and everything that the app needs to run. The container is simply running instance of your image, and the Docker file is instruction to build the image, and the Docker Hub, it's a cloud registry to store image. So this is a concept just to get familiar with. So let's see the demo. I think it will be more clear. Okay, so let me share the screen. Okay, there is a question on the chat. Like, how is Docker handle that? I mean, how is it allowing us to run apps, package, or whatever on the different ways or machine. In short, what is behind Docker allowing us to achievability would be best if you explain the number to just way to understand the core concept of it. So Alama, you said if you have Docker up in your machine, can you show the basic concept inside Docker and how we run our project? Yeah, I'm going to show you a demo now. So Daniel, yeah, we will see that also on the demo. And if I don't answer your question, now. So generally Docker is going to install all of your requirements. Requirement text or halara. So like everything download argo also like የሚያስቀምጠው. So it won't be needing any of your codes or any of your refer ማድረግ አይጠበቅበት. Like everything ይወስዳል ማለት ነው. So think of it as like ሬሲፒዎቹን everything ይወስዳል. So it will cook on its like own kitchen. Like so it doesn't have to run back ማድረግ አይጠበቅበትም ማለት ነው. So all of your dependency requirement ላይ ይወስድና it will build. So just እንዴት ነው grab and go መሆን ይችላል ማለት ነው. Think of it like as take away ነገር container አለ, like everything is ውስጥ ነው ያለው. The recipes እንትን you don't need like again መስራት አይጠበቅብህም. So እሱን ወስደህ anywhere ብታረገው ሊነክስ ላይ ራን ብታረገው ይሰራል፣ macOS ላይ or Windows ላይ ብታረገው ይሰራል ማለት ነው። ዲፔንደንሲዎቹን everything እንዲሰራ ተደርጎ ነው like Docker create ተደርገው። So deploy ስታረግ any ማሽን ላይ እንዲሰራ ሆኖ ነው deploy የሚደረገው ማለት ነው። So we'll see it in the demo. አልመለስኩልህ will okay. So for this demo, now just I created some like generic data for you guys to run. So ከክላሱ በኋላ ስለምሰጣችሁ you don't need any external data, just synthetically create ያደረግነው data አለ. So don't worry about this when you see it. Just demo data create ስላደረግን ማለት ነው። when you see it ግራ እንዳትጋቡ ነው የምነግራችሁ. So this is just creating the synthetic data. Credit risk data ነው create ያደረግነው for this demo purpose only. Okay. So this is generally የምናደርገው አሁን we're going to train this data set. train ካደረግነው በኋላ like በሚል flow እንዴት ነው track የምናደርገው የሚለውን እናያለን. like the interface and so on and the API documentationዎቹን እናያለን and like Docker like run ሲያደርግና build እንዴት እንደምናደርግ እናያለን. So the first thing you do is go to let's see here Docker site and download ለእናንተ የሚሆነው ሊነክስ የምትጠቀሙ ከሆነ ሊነክስ macOS ከሆነ macOS like just download ብቻ ነው የምታደርጉት. Then the application, you need the application locally for now. Yeah, before that, let's just see what our demo is all about. So the first one, create pre-processing pipeline. This is going to be the so we create a pre-processing pipeline that handles numeric column and categorical column create የሚያደርግ pipeline create እናደርጋለን ማለት ነው። So ምንድነው የሚያደርግልን? numeric value fill missing values እና scale ያደርግልናል። categorical column ደግሞ fill missing values and one hot encoding I think ከዚህ በፊት ተምራችሁታል። So for categoricalዎቹ one hot encode ያደርግልናል። for numericoቹ ደግሞ scale ያደርግልናል ማለት ነው። So here the numeric column in the categorical column እናወጣዋለን for object. Then so ML models need number. So that's why scaling ማለት simply ግራ ሳይገባችሁ እንድናልፍ scaling means የተለያዩ ቫልዩዎች ሊኖር ይችላል አይደል? ለምሳሌ ብር ልናረገው እንችላለን or anything ብቻ ቫልዩዎቹ በጣም ቫሪ የሚያደርጉ ከሆነ to column like ስኬል ስናደርገው in some proportion ከአንድ ከዜሮ እስከ አንድ ልናደርገው እንችላለን። ለምሳሌ scaling means in simple term for you guys to understand ለምሳሌ አንዱ ቫልዩ ላይ like 1000 100,000 like 10,000 ምናምን ቫልዩዎች ሊኖሩ ይችላሉ on the second column ሌላ ዳታ ቢሆነው ማለት ነው። እነሱ ላይ ደግሞ 2 3 ምናምን ሊሆን ይችላል። so ይሄንን አንደርስታንድ ማድረግ it's going to be harder for the model so we scale የሁለቱንም ቫልዩ በፕሮፖርሽን አድርገን to 0 to 1 ብናደርገው በፕሮፖርሽን ነው የሚሰራው። so የአንድ ሺው እና ሁለቱ ምን ያህል ፕሮፖርሽናል አለው የሚለውን ክሬት ያደርግልናል ማለት ነው። so it will be all the same value ከ0 እስከ 1 ቫልዩዎቹ ፕሮፖርሽኑ አይቀየርም ግን ያው the numbers will change ማለት ነው። so this is what scaling means and so here also I've put the comments here numbers should be on similar scales like h25 versus like amount 1000 would be confusing for the model so the transformers በመጠቀም በmean 0 and standard deviation 1 አድርገን like example 25ን ወደ 0.3 ሊመጣ ይችላል ማለት ነው። this is what it does just ካቴጎሪካሉ ደግሞ one hot encoding-ን ይሰራል። you guys learned that in the previous classes you can refer that so this is just what it does ይሄኛው like create pre-processing pipeline then we train the model when we train the model create and train the full pipeline like pre-processing and logistic regression classifier so the demo ላይ የምንጠቀመው just we going to train the logistic regression the pre-processing-ን ደግሞ መጀመሪያ ይሰራልናል ማለት ነው scaling እና encoding so the pipeline chains pre-processing and modeling together so this is what the pipeline የሚያስፈልገን ለዚህ ነው one object to save loads and use when you call pipeline predict it automatically pre-process first and then predict so this is how you chain them together pre-processing መጀመሪያ ይሰራልናል then ነው ሞዴሉን ትሬን የሚያደርግልን ማለት ነው so አንድ ላይ ነው ቼን የምናደርገው sometimes ልንረሳ እንችላለን ስኬሊንጉን or እንትን everything is going to be a mess ማለት ነው so if we create ግን pipeline እና ስቴፑን ከነገርነው this is steps as you hear pre-process and classifier ማለት መጀመሪያ ይሰራልናል the pre-processing here ከዛ the modeling part ማለት ነው ትሬኒንጉን ይሰራልናል ማለት ነው so this is just logger run አድርገን እንየው just so this is just logging ነው የሚያደርግልን creating the model train the model here እንደናየው ማለት ነው አውትፑት ላይ so return the pipeline ይመልስልናል so እዚህ ጋር pipeline dot fit ስንለው pre-processing-ን ቀድሞ ይሰራል ከዛ modeling-ን create ያደርግልናል ማለት ነው so in just one line so training is complete here when we run it so ከዛ evaluation አለ already evaluation you are familiar with for this demo ግን accuracy እና arrows ብቻ ነው የምናየው ማለት ነው accuracy like how many predictions are correct እና how well the model rank prediction የሚለው ነው የምናየው ማለት ነው so logger information like evaluating model here return 0 or 1 just the like line by line understand ማድረግ አይጠበቅብንም for now just the main concept is train አድርገን እንዴት ነው deploy የምናደርገው or እንዴት ነው ዶከራይዝ የምናደርገው የሚለውን ለማየት ስለሆነ ማለት ነው just understanding እንዲኖራችሁ ነው how the whole process is going so here you have to save your model file path-ን እንሰጠዋለን models የሚባል folder create አድርጎ እዚህ ጋር like the pickle file ያስቀምጥልናል ማለት ነው train ያደረግነው so this is where your model is saved as you can see here model.pickle so API-ን ለወደፊቱም ስንጠራ ከዚህ ላይ ነው ፌች የሚያደርገው ማለት ነው so this is your model saved model so this is just your main function that loads data training-ን የሚጠራልን pre-process-ን የሚጠራልን like everything so this is where ML flow comes in so tell ML flow where to save experiment data local folder this one ማለት ነው so it will create this folder here and it will save everything track የምናደርገውን on locally So this is what ML flow tracking is. ML flow ሴት ኤክስፐሪመንት ማለት ክሬዲት ሪስክ ዴሞ የሚባል ኤክስፐሪመንት ክሬት አድርግልን ማለት ነው። ሶ አይ ቲንክ እንትኑን አይተን ወደዚህ ብንመለስ ይሻላል ሞር ክሊር እንዲሆን ማለት ነው። let me show you guys. Okay. So ይታያል አይደል?
Yes, ይታያል።
Okay. So this is the ML flow UI ማለት ነው። So ML flow UI ብለን ክሬት ስናደርግ it will open this one. Just download ስታደርጉት everything just a pipeline pip install ብላችሁ ML flow ክሬት ካደረጋችሁ በኋላ you don't need any external thing. ML flow ትራክ ካደረጋችሁ በኋላ we'll back to the code ግን ያው just visualize እንድታደርጉት ነው። So ቀደም ምንድን ነው ያልነው like experiment ኔሙን ነው አይደለ ክሬት ያደረግንለት credit risk demo የሚለው here as you can see here credit risk demo የሚባል experiment create አድርግልናል ነው ML flow. So it created this one. So ውስጡ this is everything logged inside this block saved together ማለት ነው like ML flow start run ስንለው everything ከዚህ በኋላ የምናደርገው እዚህ ውስጥ ትራክ ይደረግልናል ማለት ነው። so ትራክ የሚደረግልን ስፔሲፋይ እናደርግለታለን like ፓራሜትሩን model type logistic regression ነው test size 0.2 random states like 42 ለምሳሌ this is run ያደረግናቸው ናቸው። so let's just change ይሄንን እና for example okay for some reason it's not running but like so ፓራሜትሮቹን ሴቭ እናደርጋለን already like an hour before run ያደረግነው አለ like 19 hour like 21 hour ትላንት ክሬት አደረገው ለምሳሌ ዴሞን ያደረገልናል ማለት ነው። so ኤክስፐሪመንቶቹን እዚህ ጋር ነው የሚያስቀምጥልን። so when you go here let me show you guys here ሜትሪክሶቹንም ML flow log matrix ብለናል ፓራሜትሩን ብለናል ሜትሪክሱን ብለናል። so this is the parameterዎቹን ሎግ የሚያደርግልን test size 0.5 random state 42 model type regression so እነዚህ ነገሮች ሴቭ ያደርግልናል ማለት ነው። it's just ሎግ የሚያደርግልንና ኮምፔር የምናደርግበት ቱል ነው ማለት ነው። so ሜትሪክሶቹንም እዚህ ጋር accuracy 0.79 መጥቷል ROC like 0.87 መጥቷል ለየትኛው ፓራሜትር ለዚህኛው ፓራሜትር ማለት ነው። so the runs ለምሳሌ ይሄኛው በ0.2 ነው ራን ያደረግነው ያኛውም በ0.5 right so test size 0.2 ሲሆን ደግሞ this is the accuracy and the ROC like for this case እንደዚህ ነው ያደረግነው ግን for you guys like recall ሊኖር ይችላል ብዙ ሜትሪክሶችን አድ ልታደርጉ ትችላላችሁ። so እዚህ ጋር ነው ሎግ የምታደርጉት just ML flow dot log metric ብላችሁ የምትፈልጉትን ፓራሜትር or የምትፈልጉትን ሜትሪክስ አድ ታደርጋላችሁ ማለት ነው። so it will just track everything so change ስታደርጉና you can compare them እዚህ ጋር መጣችሁ ሞዴል ሲስተማቲክ ሜትሪክ traces like artifacts ሞዴል ፋይላችሁን ፓዙን የሚያስቀምጥላችኋል so on like you can ፋይላችሁ ላይ ክሬት አድርጋችሁ you can explore more but this is the like the whole concept ማለት ክሬት ያደርግላችኋል። ሶ ሞዴሉንም በዛው ክሬት ያደርግላችኋል ማለት ነው። ራን ስታደርጉት ሞዴሉም አብሮ ክሬት ይደረጋል አይደል? something ሲቀየር so this is where like the models also saved so ማየት ትችላላችሁ። አሁን ይሄ ቨርዥን 1 ስለሆነ ነው። ቨርዥን 2 ሲሆን እዚህ ላይ ማየት ትችላላችሁ። ቨርዥን 1 የመጣበት በምን ትሬን ተደርጎ ነው የሚለውን እዚህ ጋር ሎጉን ማየት ትችላላችሁ ማለት ነው። so this is the basic concept of ML flow. more detail on like when you guys work on it ማየት ትችላላችሁ። ግን ML flow yeah this is what it does. so next ምናየው so the interface.py like load the model and make prediction. This module provides helper function that an API uses load model and predict ማለት ነው። so a helper functionችን ነው የሚሆነው። ሞዴል ፓዙን ይነግረዋል። everything just load the model, use the model level variable. so for better performance ሞዴሉ አንድ ራን ሲደረግ መጀመሪያ ራን እንዲያደርግ ማድረግ አለብን። ለምን every time someone asked ሞዴሉ like እንደ አዲስ ሪራን መደረግ የለበትም right? so this is what it checks. መጀመሪያ ሞዴሉ or like when we start our project ሞዴሉ አንድ ራን ያደርጋል ፋስት API so ከዛ ከካሽ ላይ ነው የሚወስደው ማለት ነው። so every time ሪራን የሚያደርግ ከሆነ computational going to do ማለት ነው። okay so this is the API main function like ከሱ በፊት ስኬማው አለ። ስኬማው ማለት ቅድም like ያልነው ክሬት እናደርግለታለን which fields are like field አለ like credit history, duration, purpose, credit amount ይሄ for this demo ነው። ለእናንተ ደግሞ የሚሆነውን ክሬት ታደርጋላችሁ like ምን ፊልዶች አስገብተን ነው like output እንዲሰጠን ምን ፈልገው or like this is the JSON ፎርማቱ ማለት ነው። so just to be clear confusing እንዳይሆን ከዚህ መተን አይተነው ብንመለስ going to be good yes ማለት so ቅድምም ብያችሁ ነበር like redoc እና docs አለው አይደል? so this is just automatically documentation ይሰራልናል ማለት ነው። አልዝ ቼኩን ለምሳሌ እኛ just for now schema እንድታዩት ነው መጀመሪያ we'll go to the main function. so this is the schema like purpose, credit amount, as you can see here like predict credit risk for a customer, send customer data and receive, default probability and chance ይሄ just እኛ ያስገባነው ነገር ነው የሚሆነው እዚህ ጋር so the schema is JSON format. This is checking status, duration, credit history, purpose, like everything ከዲስክሪፕሽኑ ጋር አስገብተንለታል። this is just documentation ምንም ያደርገው ነገር የለም። የሚቀበለውን ነው የሚነግረን ሪኩዌስት ሳምፕሉን ማለት ነው። so this is the request sample, response ሳምፕሉንም ይነግረናል like clear ከሆነ 200 like response sample 422 like error ከሆነ እንዲመልስልን this is the response default probability እና risk label low ብሎ እንዲመልስልን ነው just this is template ብላችሁ አስቡት so it's just documentation. so when we come to this one API this is just health check ነው right now ብንለው it gives us like status okay, model loaded is true. So this is just health check ለማድረግ ያክል ነው። so this is where the prediction እና the API create የሚደረገው ማለት ነው። so this is the predict, the post predict ማለት ነው። so post predict ማለት እኛን እንልክለት so እኛ ስንልክለት ለምሳሌ ቼኪንግ ስታተስ ሎ የሆነ ዲዩሬሽኑ like 12 የሆነ ምናምን ልንቀይረው እንችላለን። this is the example schema. let me try it. አላሳያችሁ try now execute ብንለው see አሁን ይሄንን ኤግዛምፕሉን ወስዶ ነው just ፖስት ያደርገልን ማለት ነው። ፖስት ማለት just post predict እና ያዘዝንለት for what, for this values ይሄኛው ጄሰኑ ነው like ዶክመንቴሽኑ ነው። ያው usually እንደዚህ አይደለም የምትጠቀሙት like streamlit app ሊኖረው ይችላል or for this case I created a streamlit app so you guys can see ምን እንደሚመስል. You're not required to do streamlit online for this project but this is what it seems like. JSON formatun ይቀበላል then it will gives you this output ማለት ነው. Default probability is 0.5. ይሄንን ስታስገቡ አውቶማቲክሊ ፌች ያደርግላችኋል ማለት ነው your prediction. so this is what the API is. every detail one by one made actually ግን ያው you get the whole idea, right? fetches the data and it gives you the result ማለት ነው the JSON format. let me show you with this one. So this is the Streamlit application which we build for this case only. So API URL ላችሁ ታስገባላችሁ ማለት ነው። see here the API URL, the predict ቀደም ስንል የነበረውን which is this one. so it gives you a URL ምንም ሌላ ነገር complication or yeah, sorry guys, one moment. Sorry for the interruption. Okay, where were we? Okay, so API URL ን ሰጥተነው ነው የምንጀምረው ማለት ነው. so we're not gonna go in detail like Streamlit እንዴት build እንደሚደረግ ምናምን as you guys already seen and worked on it, and for this purpose እና to show you and visualize everything. so ይሄ ለምሳሌ አፕሊኬሽናችን ነው ነበር credit risk predictorአችሁ ማለት ነው. so you gave it a value like when you do this JSON value ነው የሚቀይረው ማለት ነው, which is እነዚህን values ማለት ነው. so checking status low ነው አይደል? like this is just interface wise ማለት ነው, ግን ያው it's going to give it a JSON value. so loan duration ን መቀየር ትችላላችሁ. for example credit like it's bad or good, just the values ተቀይሩትና predict ስትሉት it will fetch the prediction ማለት ነው. ይሄንን ቫልዩ በሞዴላችሁ ውስጥ አሳልፎ ፕሪ ፕሮሰስ አድርጎ ያወጣላችኋል. ሶ ሪስክ ሌቭሉ ሎ ነው ብሎ ነገረን። ዲፎልት ፕሮባቢሊቲ ኢዝ ላይክ 7.9 ማለት ነው። ሶ እዚህ ጋር እንደታዩት this is what we did ማለት ነው። ዲዩሬሽኑን ላይክ 41 አድርገናል። ለምሳሌ ላይክ 54 ብናደርገውና ፕሪዲክት ብናደርገው the duration is 54. so this is what it gives to the API ማለት ነው, the JSON file. so this is it ማለት ነው። በቃ just አፕሊኬሽናችሁ ውስጥ ኢንተግሬት እንዴት ታደርጉታላችሁ ማለት ነው። just ሌላ ነገር የለም። so one thing የቀረን like docker ነው አይደል? let's see our docker file. Okay, so comment አድርጌበታለሁ on everything እንድታዩት step by step when you have the file. So like start from a small Linux image ብለን ነው create ያደረግነው from 3.11 slim. This is just a syntax for a Docker file ማለት ነው. You need to create a Docker file always when you want Dockerize እና like Dockerize ማድረግ ስትፈልጉ ፕሮጀክታችሁ ማለት ነው. So all commands after this will run from the app ማለት ነው, working directory inside the container like our project live and from the app ማለት ነው. So step 3 is copy the requirement file. Daniel ቅድም ስጠይቀኝ የነበረው I think this one. So Docker cache each step, so if requirement text doesn't change, it won't reinstall package or faster rebuild ማለት ነው. ድጋሚ ቢውልድ ካላረግነው በስተቀር ምንቀይረውን ነገር አያይም. So first copy requirement text ነው ይወስድና it will install ማለት ነው. So that's why sometimes build ስታረጉ ዶከር በጣም ጊዜ ይፈጃል. ያው እንደ computational power ቢለያይም it will take longer or shorter, ግን it will install every dependencies ማለት ነው. So the bigger your project is, like the Docker containerized የሚያደርግበትን time it will take longer ማለት ነው. So every dependency copy ስለሚያደርግ which is like this one ማለት ነው. For our case just simple ስለሆነ fast API Unicode like እነዚህ ነገሮች በሙሉ ኢንስቶል ያደርግልናል ማለት ነው. So we copy only what we need to keep the image small. For now copy the model as well ብለናል. So expose አድርገን በዚህ ራን እናደርገዋለን ማለት ነው. So when we run it, let me show you. You can take the demo from this. This is how you build your Docker ማለት ነው. ዶከር ፋይላችሁን ካስተካከላችሁ በኋላ ዶከር ቢልድ ብላችሁ like ስሙን ነው የምትሰጡት, credit risk API like everything. So for us it is simple, ትንሽ ሞዴል ስለሆነ just build አደረገልን ማለት ነው ዶከር. So build ሲያደርግልን this is the Docker setup and this is the container already run ስላደረግነው መጣልናል ማለት ነው. So this is just the container credit risk API የሚባል አለ. ይሄንን ኔም ራሱ ነው የሚሰጠው automatically ኢሜጁን ክሬት ያደርግልናል ማለት ነው. for now like run ስላደረግነው already delete ከምናደርገው just in run ስታደርጉት it will show up here. Sorry, one time. Sorry, so this is how you build your Docker file. Then how are you going to run it? የሚለው ደግሞ አለ ቀጣይ build ካረጋችሁ በኋላ you have to run your Docker file. So let us copy this one. መጀመሪያ እንድታዩት ፈልገው ነገር this is off, right? It's not running or anything. So after we run ስናደርገው it created another one. Silly Alegma min 11 seconds ago because that this rebuild ስላደረግነው ማለት ነው. that this rebuild ስላደረግነው ሌላ image create አደረገልን. So one thing you have to be sure እና remember ማድረግ ያለባችሁ ነገር you don't have to build every time. Just change ከሌለው on your codes or on your like predictions. You don't need to build, you just have to run. So only use this command docker build only once. ሞዴላችሁን ካልቀየራችሁ or ሞዴላችሁን like ልናሻሽል ነው ብላችሁ parameters or anything ካልቀየራችሁ you just only build once. just ከዛ በኋላ run ነው የምታደርጉት ማለት ነው every time መጠቀም ስትፈልጉ. So this is ከዚህም ላይ ኦፍ ማድረግ ትችላላችሁ። So you can see እዚህ ጋር ይዘጋዋል። You can also like run it from here. ስታርት ማለት ትችላላችሁ። So it's the same thing ማለት በኮማንድም በዚህ ማለት ትችላላችሁ። አንዴ ቢውልድ ካረጋችሁ በኋላ you can control it ማለት ነው። So as you can see here ፋስት ኤፒአይውን ነው ዶከራይዝ አድርገን ፖስት ያደረግንለት። ፎር ናው ስትሪምሊቱን አድ ስላላረግ ነው ማለት ነው። ውስጥ just the model እና the source of ፋይሉን ያደረግነው። So this is what you will get። ግን ያው don't get confused, just /docs ማለት ትችላላችሁ። it will gives you this ማለት ነው። So አሁን ኤፒአይውን ቅድም አንድ ያላሳያችሁ ነገር ሎካሊ ነበረ ራን እያደረገን የነበረው። ቆይ let me stop it and see it. Let us also shut down this one. So ሁለት አይነት ስቴፕ አለ። always like dockerize ላታረጉ ትችላላችሁ right? So then ፋስት ኤፒአይያችሁ ራን መሆን አለበት መጀመሪያ። So this is where you should run your fast API locally ሲሆን ማለት ነው። ልዩነቱን ላሳያችሁ ነው። So locally ሲሆን you copy this one, you record source API and load. አሁን ዶከሩም አልተነሳም or anything, just make sure like ይሄኛው እየሰራልን አይደለም right? So it's not running ማለት ነው። APIያችን ራን እያደረጋለን። when we run this ዶከሩ ራን አላረገም፣ just locally ነው ራን ያደረግነው። It's working now, right? Like what if in አቆመን ስናቆመው አይሰራም, like we stop our fast API. Then since we dockerized everything, fast API ሆንም everything docker ውስጥ ስለከተት ነው, all we have to do is like start our docker ማለት ነው። So when we start our docker still fast APIያችን ይሰራል ማለት ነው። So we don't need to run API አሁን ራን እያደረገ ያለው ከዲቫይሳችን ሳይሆን ከዶከሩ ላይ ነው ማለት ነው። So this is what containerized is. So explore አድርጉት. There is nothing to it. So this is what it does. So Daniel, I think ጥያቄን መልሼልሃለሁ ብዬ አስባለሁ።
I feel it.
Okay. Hi.
Okay. When we have a change on the model on in the API, so we need to run manually every time after the change our Docker image.
Okay, so Dockerun usually የምንሰራው like deployment ላይ ነው right? Deployment ማለት when we are ready to deploy or this is our final ብለን ስናስብ ማለት ነው። So before that we have ML flow right? So ML flow ላይ ትራክ እናደርገዋለን። So ይሄ ኤቭሪቲንግ ትራክ እያደረገልን ነው። So ስንቀይር or ስንል like ቨርዥኑን ያሳየናል or everything. And yeah. So እዚህ ጋር like ኤክስፐሪመንታችንን እየሰራን ነው right? Experiment is not one thing አይደለም, just everyone like የትኛው ፓራሜትር እንደሚሰራ አያውቅም right? So like last time I think ከመዋጋ ክላስ ስትወስዱ ራንደም ሰርች እና ግሪድ ሰርች አይታችኋል። So ራንደም ግሪድ እና ራንደም ሰርች እና ግሪድ ሰርች የሚሰራለን the best parameters ነው የሚፈልግልን for our model to the best accuracy ማለት ነው። So የተለያዩ ነገሮችን እየቀየርክ ትሞክራለህ፣ everything እዚህ ላይ ታየዋለህ። So when you are happy with your model እና your output you will deploy, you will build ማለት ነው። ምንም like your docker file build ታደርጋለህ አንድ ጊዜ። So it's not like repetition የሆነ ነገር ስንሰራ just continuously build የምናደርገው ነገር አለ። like when you're finally እና this is my project ብለህ ስታስብ ነው create የምታደርገው deployment ዶከሩ ላይ ማለት ነው። So you don't need to deploy everything. ጥያቄን ከመለሱ ከገባኝ እንደዛ ነው አይደል? ጥያቄ
Yes.
Okay. Okay. Any other question? Yes. Daniel, መልሼ ላውጥ again?
Yeah, thank you. One more thing.
Yes.
No, we have like a Docker now, right? Like Docker is going to the deployment process. So somebody has to have a Docker ማለት ነው። አሁን ለምሳሌ የኛን ፓኬጅ ኦር የኛን ፕሮጀክት አውርዶ መጠቀም ከፈለገ የሆነ ሰው like clone አድርጎ whatever. So they need to have a Docker ማለት ነው. So
Yes. Yeah.
okay. Okay.
Okay. So ሌላ ዲፕሎይመንቶች አሉ ፎር ናው ዶከር ላይ ስላቆምን ነው እንጂ ፕሮዳክሽን ዋይዝ ሲሆን ዜር ኢዝ ሬንደር የሚባላል ሀጊንግ ፌስ ላይ ፍሪ ቲሮች አሉ ኦር ኤምኤል ፍሎ ላይም ክላውድ ላይ ሬጂስተር ማድረግ እንችላለን። ሞዴል ሬጂስተር ያለው ስንል አልነበረ ቅድም? ኤምኤል ፍሎ ሞዴል ቨርዥን 1 ቨርዥን 2 እያለን ክሬት እናደርጋለን። ክሬት ሞዴል ብንለው ሞዴል ኔሙን ሰጥተን ቨርዥኑን ክሬት እናደርግለታለን። ከዛኛው የትኛው ነው ቤተር የሚለውን ኤቭሪቲንግ ማለት ነው። ክላውዱ ይሄኛው ሎካል እየሰራን ስለሆነ ክላውድ ላይ ሬጂስተር ማድረግ እንችላለን ሞዴል then everything ከዛ ኦኬ yes. I thought that was okay. So Daniel was asking የጠየቀ የነበረው how are we going to use ሌላ ሰው ቢጠቀመው ማለት ነው። so Azure ላይም ሊሆን ይችላል AWS ላይ ዲፕሎይ የምታደርገው ኤቭሪቲንግ እንትኑን አይደለም፣ በቃ ጀስት ዶከር ፋይሉን ነው ወስደህ ዲፕሎይ የምታደርገው ማለት ነው። ሶ ኢፍ ኤኒዋን ዋንትስ ቱ ዩዝ ያንተን ፋይል ዶከሩን ማግኘት አለበት ማለት ነው። ሶ ዶከሩን ከወሰደ ግን ይሄ እኔ ማሽን ላይ አይሰራም፣ ይሄ እኔ ማሽን ላይ አይሰራም የሚለው ኮንሴፕት ይጠፋል ማለት ነው። ሶ ኤኒዌር ኤኒ ኦፕሬቲንግ ሲስተም ቢሆን ይሰራል። ሶ ኢት ኒድስ ቱ ሃቭ ዩር ፋይል፣ ግን ፋይልህን ኢት ዳዝንት ሪሊ ኒድ ዩር ፋይል ራይት። ዶከር ፋይሉ አለ አይደል ኦልሬዲ ክሬት ያደረግነው this one, where is the docker file? This one. So can't fetch ቢያደርግ ወይ pull ቢያደርግ data, you can run this and the same docker ያገኛል ማለት ነው። So you don't need the file per se, just the docker file ውስጥ ካለ ድረስ this is an instruction how to build the docker, so it doesn't really matter ማለት ነው። መለስልህ ጥያቄን?
Yeah, thank you.
Okay, Daniel. Thank you for asking. Any more questions, guys? Okay, Nathan?
When you use the ML flow, when you use the ML flow UI, you have the models and the frame.py, but I don't see it in my UI.
The what?
I'm not seeing it in my UI.
Everything. So have you already work on the ML flow on your project?
Yes.
Okay. So have you put the parameters or everything? The log metric?
Yes, I did.
Manually አድርገኸው አልመጣም ከኤምኤል ፍሎ ነው? it should come. So experiment ላይ ገብተህ inside of the experiment when you click the each, then the matrix, the parameter, it's not showing up.
Yeah, nothing.
Okay, that's weird. We're going to have 101 session later, no, it should come እዚህ ላይ ሎግ ካረከውና if you already write it, it should automatically come. Just UI እዚህ ላይ የሰራነውን ነገር ነው የሚያሳየን, nothing else, nothing more or nothing less ማለት ነው. So it should come. It's going to be a bug. It's okay. Okay. Any other question, guys? I think the whole concept, just generalize አድርጋችሁ every detail, you can guys search and see more details, but this is the whole concept. So this is how you deploy a model and make it usable for like everyone else in your projects, later integrate with Paragut. This is how it's going to be in a workflow. Okay. Alamayo?
Okay, thank you. And local host like API model, how to get like from my VS Code. I want
Local
to-
ምን ላይ
Yeah.
አንድ ጥያቄ እንድገምልህ
In my VS Code, just there is a code that I want to see in localhost. It means localhost ላይ ለማየት API እና ሞዴሉ ማለት ነው።
ኦኬ እንዴት ነው የምናደርገው?
localhost ላይ
ያ አሁን ኤቭሪቲንግ ሎካል ሆስት ላይ ነው እየሰራ ነው ያለ ነው። ባይ ዘ ዌይ ላይክ ነቲንግ ኦን ዘ ክላውድ ኦር ኤኒቲንግ
ኢን ብራውዘር ለማለት ነው።
የስ ኢን ብራውዘር ነው እየሰራ ነው ያለ ነው። ላይክ ኢን ብራውዘሩም ክላውድ ላይ አይደለም፣ ጀስት ከኛ እንትን ላይ ነው ራን ያደረግነው። ሶ I think I have put all the commands here. I will later add them as well. So you have to run this one locally ከሆነ የምትሰራው ማለት ነው። ሎካሊ ስል ቅድም አሳይቻችኋለሁ ዶከር ሲሆንና ዶከር ሳይሆን how the API reacts and locally run ማድረግ ከፈለክ API without any docker or anything, you just have to run this command on your code base. So this is how you run, then automatically ይሰጣል እዚህ ጋር ሊንክ ማለት ነው። You just have to click this one.
Okay, got it.
So just እዚህ ጋር like docs መጻፍ እንዳትረሱ or docs or redoc ማለት ነው። አንዱ ዶክመንቴሽን እንድታገኙ ከዛ እዚህ ጋር just መሞከሪያው ነው as you guys already see. Just try it out የሚለውን like መጀመሪያ መሞከር አለባችሁ right your API is working or not የሚለውን ቢልድ ከማድረጋችሁ በፊት. So this is just execute. So code 200 የመለሰልን እየሰራ ስለሆነ ነው። ባይመልስልን ኖሮ ግን like you would have seen ባይሰራ ኖሮ docs response for 22 ነበር የሚመጣው ማለት ነው። So since it's working, it's going to be 200. So for your question, yeah, everything is ጋር አንስታረጉት ዶከሩንም ቢሆን like it will give you just the link locally. You just click እና ሰራላችሁ ነው። Okay,
Thank
any
you
other
very
question? You're welcome, Alamayo. Thank you for the comment. This is Wireless. Thank you so much. Okay, thank you. Okay. I think we can end the session here. So explore with your project as well. So since you have like the general idea of like how it all connects. Okay, Tob?
so የኩበርኔትስ ሴሽን ኖርማል እንዴ?
ምን አልከኝ?
ኩበርኔትስ ሴሽን ኖርማል ወደፊት
Kubernetes for this እንትን የለንም ግን ያ for this እንትን የለንም feature wise I don't think there is. You can read on it personally again. Yeah, it's just it's a good question to ask. Dockerize like that. You can read on it. For now, it's not on the class.
Sure.
Okay, guys. Thank you for being here. Have a good afternoon.